All right, let's do it. So thanks all for coming to my talk, first of all. My name is Joshi, and I'm presenting on behalf of myself and my colleague Dan Connolly, who can't be here because of passport issues. He did a lot of the coding here, and I did, a decent amount of it too, but, make sure some of the credit goes to him too. So what I'm going to be doing today is basically demoing a couple of example dApps that we've been working on. There's two of them, and getting to the point of having minimum working dApps was a little bit of work, a little bit more work than I would like for a would-be RChain dev to have to overcome in order to write a dApp. And so along the way, we've written some tools that will make that process easier. Things to like wrap the gRPC interface into something a little nicer. So like we did one in JavaScript, so it's a Node.js module. And then the other one that we were coding on until last night that's not 100% ready, but is ready enough that I can demo it and give you a sense is a like client-side browser-based signing tool so that you can cryptographically sign transactions and send them up to the blockchain. And so the takeaway that I want you guys to have are basically how you can write a smart contract, which isn't terribly hard. You spend a week learning Erlang, you can write some pretty decent smart contracts, and connect those to your end user. So the user experience that we want isn't, I wrote a smart contract, now you have to install 3 things and read a tutorial and be a CS major and then you can use it. We're looking for a UX more like, I wrote a smart contract in a front end and now my grandma can interact with it, or something like that. And so we're definitely not at that stage yet, but we're taking steps toward that stage, and we just want to show you guys what we've done and invite you to join in the journey. My background is that I was a high school teacher for a long time, and so I always like to have sort of discussion-based classes or presentations or however it is. So not only feel free, but actually feel encouraged to interrupt me and take us on tangents or whatever it is. It'll be a better presentation if I address the questions that you guys want to have answered. And maybe I won't be able to answer them, that's pretty likely, but at least some or a bunch of them I will be able to. So speak up when you want to. And then if we have time, we'll kind of see how it goes, but we might even be able to do some workshopping at the end, because I've written this lesson that's called Write Your First dApp, and it'll take you through the process of building the first example dApp that I'm going to show today. So the first one, and the simpler of the two, is I call it nth caller, and it's basically a small game that simulates these things you hear on the radio station, where the DJ says, "Great news, the 10th caller is going to win tickets to the concert tonight," and everybody starts calling up, and the first people are told, "Well, sorry, you were caller number 4, or sorry, you were caller number 6, you don't win," and then when you're the lucky 10th caller, you get the concert tickets. So I don't think I have it running, so you guys will actually get to see the uglies of how to start one of these up. I've written some scripts to make it a little easier. So I'm not using the testnet or anything here. I'm going to start my own R node locally on my laptop, and it won't communicate with the blockchain, but that's only to make it a little bit faster and easier to work with and not pollute the public blockchain. So these are the steps that you'll use to really deploy a smart contract. So the first one I do like this, npm run fresh. And what that's going to do for me is start up a brand new R node. So it clears out my data directory, and it just gets a fresh RChain node working that we can call into. And when you first bootstrap a blockchain, there's no contracts on it. So I can't just call it up and expect it to tell me I'm the 3rd caller. I have to actually deploy a contract that does that. So I wrote a script for that too. Whoops. And you'll probably see lots of like nervous typing mistakes. You know how hard it is to code on the screen. So the first response success here tells me that my deploy was successful. That means the node that I was running in my other terminal received the contract. And then the second response here is that my node successfully proposed a block and propagated it around the network. And right now the network is just my node, so that's not super exciting, but what we see here is that it's on chain. So if I flip back to the other terminal, we can see right here, how's the text size? Yeah, okay, good. All right, cool. What was that? You're in the front row, yeah. How you doing back there? Can you read my screen? Yes. So we received a deploy, and that was part of me deploying the contract. When we get to this stage, though, only the node that you called up has the contract, and then when we get, let's see, this one, when we sent block number 1, that means that now the block is propagated. Again, we're kind of in a limiting case with only one node, but now the whole network knows about my contract, so it's out there officially. So that's good. It's there, it's running. We're at a state now where I could write up some Rolang code that calls it up and says, hey, my name's Joshi, I hope I won, and prints out the result, like, sorry, you're the first caller or whatever. And that's fine, and that's how I started, and that's a great way to debug your contracts. Before we do that, I want to show you what, the thing that you want to say, Grandma, here's how you interact with the DApp. And so we have a nice web-based front end. And I'll show you the architecture of this in a second, but for now, just know that I started the thing that serves the front end, and I'll switch over to this browser. That's not it. That's the next one I'm going to show you. And so here it is. Nth caller game, be the correct caller to win the prize. That just describes what's going on here. And in order to make this a reusable contract so that everybody can host their own game, there's actually 2 phases. One is where you can decide, hey, I'm gonna host one of these games and invite my friends or peers to call in and win. And then the second part where it says play existing game, that's where I can call. So let's do one of these. I'm gonna create a game, and I give it a game ID called RCON 3. And so then the other thing I have to specify is what caller do I want to win? Should it be the 3rd caller or the 5th caller? And so just to make it not take forever, I'll go with the 3rd caller. And I click register. UX is always important. Really, this UI should have something that says like, pending approval, and then it says deployed and all that. And that's, I should have done it, but I didn't. So we can come back here and we can look at, again, this is the output from my R node. So received deploy, and it shows you the beginning of the R code snippet. I'll show you the code later on, but I've called nth caller factory. That's going to make an nth caller game. You can see the R, that's the beginning of my game ID, RCON 3, and then the other stuff that got cut off after ... includes this N of 3. So that game's out there, that's cool. We can call it up. Let's say, what's your name, man, in the front row? Yeah. Georgia? How do you spell it? Georgie. Yeah. Like this. Good? Oh, game ID. Oh, you're right. Sorry. Yeah, that wasn't going to work. So the game ID was RCON 3. So let's see what happens. Sorry. Try again. It's really not very polite of me to make someone else be the loser. I'll be the next loser. Okay, well, I lose too. We're in it together. Vishwak, I'm going to let you win because you were the first one other than me to successfully build this project. How do you spell your name again? Good? Nailed it. Congratulations, you win. So you were the 3rd caller. Yeah, thank you. Oh, you know what I didn't do? I didn't show you the node output while we were doing all of that. So here's one of them. This was the 1st caller. Here I am being the 2nd caller, and finally the 3rd caller. Okay, so that's pretty good. That all worked as expected. What happens if you find a game? Okay, that's a great question. So let me show you an interesting case where that will work. So let's call it just like a test game, and we'll make the 3rd caller the winner. Register, that's fine. It went through. So I called it test, right? Yeah, so I'll try to register it again. I could have the same caller number here, that would be fine, or a different one, and register again. And so what happens is, if we look up at the node output, here's where we called nth caller factory, and you can see the T from test, and then the same thing here. So at the moment, these both registered successfully. This is not a case of I could have done a little bit better, like the UI was definitely that, where I should have done better. This is a case of we're actually waiting for our node to implement what they call the name registry. So the way the name registry will work is whenever you want to deploy a contract like my nth caller factory, You'll generate a key pair, and then you'll deploy the contract to the name registry. And the way you can do it, and you can ensure that you're the only one that deploys there, is by proving that you own the private key to the place that you're trying to deploy. That's not implemented yet in our node, and so the best we can do is deploy to a public name, and that causes this very issue that you're getting at. There's now 2 of these deployed, right? So I think I made the third caller win both times. So let's see what happens. Does anyone want to take a guess what happens when I call? Definitely A isn't going to win. What was that? Ooh. Yeah, so let's see here. So 2 people lost. A and B just lost. They were too early. So we have some non-determinism now. When I'm calling this contract called test, there are 2 contracts listening on that name, and it's not determined in advance which one is actually going to receive the call. It could be that they both went to the same one, and this will also go to the same one, and we'll find out that C wins. It's also possible that they went to different ones, or that C is going to go to a different one, and so we haven't reached the third caller yet. Like maybe we had a first and a first, or we had a first and a second, but now C is going to be the first over here. So yeah, C, try again. So we don't know which one we're calling in this situation, and that's what the name registry will satisfy. So we've called 4 times now, right? So that means we've got 2 losers and 2 losers. So if my understanding is correct, E should be a winner. Here's the part where I might be embarrassed. Yay! We don't know which game E just won. It's one of the games that I called test. We're not sure which one it is. So when I do it with F, we're either going to have another winner, or we're going to have a sorry, you've already. We have a win. Yeah, but so E just won one of the games. Let's say E won over here, and we've got 2 losers over here. F could be this winner, this third winner, or F could call over here and be another loser. So F wins also. That's good. Yeah, oh yeah, like unique names, you mean? Like so that I don't have this collision of 2 contracts at one. Yeah. Right. So especially if your contract does something like, send me 10 revs, I'll ship you a case of Coca-Cola. Now here I am deploying a bogus contract on your namespace so that all your customers send me 10 revs and I run off with it to the casino, right? That's what you want to avoid. Yeah, so that's what I'm saying is not yet implemented, but it will be, and it will be soon. It's going into the next node release, 0.7, and that's called the name registry. So yeah, Jim, what's up? Yeah, that's a good idea. Yeah, right. So like, a random number generator, or you can hash something, or yeah, right. So there, in fact, in the next example that I'm going to show you, we did something similar to that, where we have to actually pull data back off the chain, and so it comes back on a channel. Well, we don't have unforgeable names implemented for off-chain yet either, and so we just generate we use a hash or a random string and hope that we don't collide. Ed. Correct. Yep, that's right. So you could guess it. Somebody watching the chain traffic could use it. Exactly right. Yeah, or someone shoulder surfing while I'm writing my hash algorithm, or whatever it is that's generating an obscure name. Yeah. So there's no cryptographic security. That's just if you want to develop stuff that doesn't have this super obvious trivial problem in the meantime, that's kind of a workaround. Yeah. That's basically right. That's really close. The registry names are actually not unforgeable because you need to be able to call them from off-chain, and you can only access unforgeable names from on-chain. But the rest of what you said is right. So I will request to register a new one of these registry names, and the name is going to be something like row : whatever cryptographic, like ed 25519 is my signature algorithm, and then my public key. And so there's a blessed contract, and this isn't what's written yet. The blessed contract, anyone can call that name, but no one can actually deploy code there unless you can prove that you own the private key corresponding to the public key. So that's how we avoid this exact problem here. Yeah. No one can deploy a contract on the name. So let's say I'm the guy who wrote this nth caller thing, and so I deploy my nth caller factory to that registered name. I can do it because I prove that I own the private key, but I obviously want all of you guys to be able to play my game, right? So then you can call in and interact with that contract. You know my public key. Anyone can send a message to row ed 25519 : my public key. And interact with it, but you can't change the contract that lives there or delete it or something like that.
So once the registry is implemented and you're using unforgeable names, is there a concept of what is the fully qualified name to a contract? What does it look like? Do you specify that?
Yeah, so it will look something. It'll look something like this. There's all these namespaces, and that's pretty hard to read. Let me get you something a little bit. Yeah, right. Oh, that's also small. Come on, head in the game here. So let me give you an example that is implemented right now. This is a really basic one. So I can do something like new standard out. Here's one thing I can do first, just row lang, new x in, and then I can write some process here, like whatever I want to do. You can also do something like this. I can say new print, and then I can give it this row : io : standard out. And what that does is it calls up this powerful capability that allows it to print to my terminal. So whenever I send a message to this new channel I made called print, the message will actually show up on standard out on my console here. This is the only thing like this that's implemented so far. But basically what you'll do when you want to call up my contract or something is I don't remember exactly what the syntax is, but it's something like this: row pub key, and then the the curve or whatever it is that you're using, and then and then my key. Yeah, exactly. So now, well, I shouldn't call it print, but we can call it Joshy's contract. So now when you want to call up my contract, you've got this name here, and you can just send on that channel whatever it is that you want to send. I guess when you're calling in the nth caller game, all you have to do is send your name and then and an ACK channel. So you send in some ACK channel here, and then in parallel you listen for whenever something comes back on that ACK channel.
Okay, so the fully qualified name then of that channel is going to be row pub key ed curve.
Bingo, it's this, yeah. This is your nickname for it. This thing that I've highlighted where I called it Joshy's contract, that's a nickname for it. The fully qualified name is here.
Plus Joshy's contract, right?
No, just the part I've highlighted. This is just what I'm calling it internally. So right now I'm writing up code to interact with one of those, and so this line 1 says call up the registry, get the thing that lives at this fully qualified name, and now, since that's a pain to type, for the rest of my contract, I'm going to call it whatever I want to call it here. So like J is a...
I was thinking there would be a convention because my public key will create lots of contracts over time, right? And let's say I want to reuse the public key.
Oh, yeah. Oh, that's a good point. Yeah, I don't know. So one thing, I'm thinking out loud a little bit here, but I think this makes sense. What you could deploy at this public key is like a request interceptor. So you can deploy a contract that says whenever someone calls this up, they need to specify which of my contracts they actually care about, and then I'll forward it on to those contracts which live at not just registry names, but actual genuine unforgeable names. Another option would be to use a different public key for every contract, or some combination of those. So, okay, I don't need to save that. Yeah, you're welcome. Yeah, there's a lot of interesting stuff going on there. Yeah, what's up? Yeah, I don't know the answer to that. That's a great question. That may be the case. It also may be the case that you can update your contract, but that, in my opinion, sounds dangerous because I could deploy an nth caller game that everybody finds fun and starts calling up, and then all of a sudden I redeploy a contract at the same address that scams you or something like that. So I don't know how they're going to solve that problem, but I'm sure they will somehow. That's a great question. Okay, so here's the architecture of how that DApp works. All of this is running on my local system right now, but it need not be that way. And I've shown these like fancy telephone wires that connect all these disjoint pieces of hardware that can live all around the world. So one of them is my R-node instance. This could be something that I own and control, or it could be a public node that exposes their interface for other people to call. There's no fundamental reason why you can't interact with the R-node directly. It exposes a gRPC interface. It's not the most convenient thing in the world, and it doesn't speak JavaScript. So what we've done right now is there's also a web server. And so that was the second thing you saw me boot up when I typed npm start. That started the web server. And what the web server does is it basically translates R-node's gRPC language into a much more familiar like HTTP interface, or like Vishwak was asking about a REST endpoint. The software that's running on the web server is a tool that Dan and I wrote, and for now we're calling it RCON API. It basically is a Node.js module. And so I started a Node.js server that runs it, and I make HTTP requests from my browser, just like every web app does these days, and then the web server forwards them on to the actual RChain. So the goal is, as a DApp developer, you won't have to go through all the pain of figuring out how to interact with the R node itself. Instead, you can just require this module that we've written and then call up RChain through this proxy exactly like you'd call up any centralized web server. So it eases the pain a little bit. Yeah, go ahead. So it's not, because it's not quite pretty enough yet. It's at the end of this talk I have links. Dan and I both have a repo. Mine's upstream and he forked it, and he's a little bit of a better, he calls it using bit tweezers. He's better at really going in and making sure all that stuff works right, and I did a little better on the like front end and the teaching part of it. So his is usually the bleeding edge, and mine is when it's stable enough that I'm willing to use it in the example dapps. So it's there. It'll go on NPM soon. We actually haven't implemented all of the gRPC API yet. That'll probably be when we do like 1.0 or something. But you can still, I just learned this too from Dan, you can actually still put that in your package.json if you're a Node developer, and you can pull it in from GitHub. Okay, and so then the final part is your web browser, and that's what we just were looking at. That's the part that you can click on and interact with. Just for the sake of time, I'm going to skip interacting via the command line. That was something, you know, like we could have written Rolang to make those calls ourselves. What I do want to show you is the contract code for this project. So I'm going to go ahead and kill it. That's the README. Here's nthcaller.row. Whoops. There. So there's a contract that I start on line 1, and it listens on this public name. So this is what I was saying, like that's the thing that the name registry will solve and avoid collisions. When you register, you specify a game ID and the number of callers that you need to win, and we saw that in the UI. I had 2 text fields for that. So once you call this contract up, we make on line 2 a new unforgeable name. What that means is that this name only exists in lexical scope from where this curly brace starts to down below where the curly brace ends. And no one or no software outside of that scope can use this name unless I send a reference to them wherever their code lives. It basically is like if you're a Java programmer, it's like a private variable is how I'm using it. I call it a state channel because it stores mutable state for my contract. It stores basically the value of the current caller. So you can see, or I guess it's the next caller really. The next caller is going to be caller number 1, and so before I even create the like game-specific contract, I seed that state channel with the value 1. So now I make a brand new contract, and it lives on the name game ID. Well, what the heck is game ID? If you remember, that's what we passed in when we called the nth caller factory. So when I typed in, I wanted to make a game called RCON3, game ID was RCON3, and now we've built a contract that lives on RCON3. When you call it, you need to specify your name, you know, like Joshi, and result is an ACK channel. So in imperative languages, there's this concept of calling a function and at the bottom it returns something. There's no such concept in Rolang, but if you want that kind of behavior where the contract gives you a result back or results back, you pass in basically a return address, a name on which the contract can send results. Makes multiple returns really easy. It makes asynchronous multiple returns really easy. What I could have done is specified an ACK channel that just says, hey, call me up here when the thing's made, and then another one that called like winner channel that says, call me up here when someone wins and tell me who it is that won. So what we do here on line 11 is we're now inside this game-specific contract, so this is one instance of nth caller. Someone calls it up with a name and a result, so we have to read in the value of the current caller from the state channel. If it's the winning one, if we're on the winning one, then we say, hey, congrats, you win. That's the result we send back on the result channel. In the more likely case that we haven't yet reached the correct caller, we say, oh, sorry, you know, game over, or you don't win, not game over. And then we increment the count and put it back onto the state channel for the next person that calls up. By not putting this back onto the state channel until afterwards, we avoid issues of two people who call up really close to the same time. They shouldn't both be told that they won. So we're sort of intentionally becoming sequential here, which is sometimes useful to do. So any questions about the code? Do you want to dig into that? I will mention, like, I definitely don't expect everyone to feel like, oh yeah, I fully understand Rolang after that whirlwind tour. I've written some resources that the links will be at the end. One is a Learn Rolang tutorial that kind of takes you through step by step, one lesson at a time, and builds this up. And then I've also written this very DApp as an example. So you can clone the repo and it gives you instructions. You'll basically be cloning starter code. And it gives you instructions of what to type where and how to deploy this thing. And so you can go through the process of building this very DApp that you're now familiar with. Okay, right, so RChain API is the tool that I talked about. Here is a link to my GitHub repo. I mean, not that you can click it from there, but you know, Google my name or Dan's name, or yeah, if you want to take a photo, that's fine. Also, pop into Discord, you know, and you just people ask about this all the time, not even knowing that we've written it, just saying like, hey, how can I interact with RChain from a web app or a web front end? And it comes up in the Discord channel like once a week or something like that. And then just to promote some of our peers' works, the people from Proof have done the same thing in Python, and the people from Resonate have done the same thing in Golang. So the ecosystem is slowly developing. So the next DApp I want to show you is a little more complex. It's still not anything like our song, but it gets at some cool stuff that's going on here. It's called Status DApp, and it basically simulates one feature of Facebook, which is posting your status. This is not exactly a quote, but it's a combination of some things I've heard Greg Meredith say. He really wants to reboot social media and get this stuff on chain so that, you guys, if you're here, know the values of making social media uncensorable and immutable and that kind of stuff. But, again, we're still missing the name registry, so there's a little bit of ugliness in this status DApp, but, such is life. I'll show you the DApp in a second, but the big idea here is it doesn't matter, in the nth caller game, it didn't matter if someone forged my identity. If Jim calls in and says, hey, I'm Joshy, and it turns out he's the 10th caller, I'm not gonna be upset about that, right? I just won concert tickets and didn't have to do anything for him. But now that we're talking about status DApp, if someone forges my identity and posts my status of like, hey, I'm a loser or whatever it is, I don't want that to happen. I want my statuses only to come from me. And so what that means is we need cryptographic signatures. So does anyone remember how Ethereum World solves that problem? There's the browser extension called MetaMask. And basically what it does is it allows you to sign transactions with your key. It does a little bit of key management so that the user doesn't have to like copy paste their private key and all those other things that are just recipes for leaking your key. And so Dan and I have started to write that for RChain as well. It's exciting. I think it's exciting. I also want to just let you know, like, it's not quite ready for the public yet. It's going to work when I demo it now because I know where all the rough corners are and pitfalls, and I'm going to carefully step around them, but we still have some more like debugging and hardening to do. But this, you can expect this to be working in, at most a month, and then we'll maintain it from there. So it's basically the same architecture, but we don't have to run the risk of someone forging our identity, and we also don't have to use the hacky solution of identifying ourselves to the server through standard methods like username and password or web key and trusting the server to sign on our behalf, because If you do that method and the server gets compromised, everything on chain is now untrustworthy, and so we wanted to avoid that. So let me show you that DApp. I'm going to kill my node here, and I'll go into our chain status. So starts out kind of similarly. I'm going to run a fresh node. Oh, I guess I could have used the same node, but fall into routines, you know. And so all right, so you guys tell me, let's see if this is making sense. I've got a brand new clean node there. Before I can interact with status DApp, what's my next step? Yeah, we need a contract, that's right. We have to get the contract on chain, so I'll do that. So we're going to get 3 success messages here. We're actually deploying 2 contracts that'll interact with one another. And then the third one will tell us again, like this block was proposed and went around the network of 1. So I can start the web interface now. Cool. And then over here. So here's the interface for status DApp. So before, just like any service, including actual Facebook, I have to sign up and give some sense of who I am. So let's say I'll just be my name. At the moment, we have the option to use this both securely, where we sign it like I've described, and also insecurely, where statuses can be easily forged and everything. I think we accidentally broke the insecure version last night, but maybe that's just a sign that it's time to remove the insecure one. So I'm going to sign my transactions, and I'm going to go ahead and click on the register button. Now let's take a peek at the node, and the only thing we see so far, oh, this is my integration test, so nothing interesting there. That came from deploying the contract. We've only got 1 block, and that also is from deploying the contract. So my registration has actually not gone to the blockchain yet, and that's because I haven't signed it yet. So there's this little extension, that's probably kind of small, but if I click on the RChain logo, we're calling this RSign, by the way. It by default uses the last key that I used, which I just called new. It shows me what my public key is, so I've got like my human readable name, and then just to make sure it's the right one, I can check my public key. It shows me what data I'm going to sign, because what we don't want is for users to see a UI that looks like this and looks harmless, like, yeah, post your status, follow your friends, and then they get conned into signing something that's completely different and maybe sends rev or something like that. So this is pretty harmless. All I'm signing is my human readable name. Enter my password that corresponds to this public key. So if there's crypto enthusiasts out there, we've symmetrically encrypted the private key so that it can't be eavesdropped on by probing into browser storage. So I'm going to decrypt my private key and use it to sign this code. By the way, 3 characters is not a good password. This is just because we're doing a silly demo. So I click on sign. It gives me my signature. This is, again, just kind of for educational purposes and for debugging purposes. But what we've done is we've created this Rolang transaction. So you can see on the name register, it's just a public channel. I'm going to send this data that I typed in. That's my human readable name. The next thing, this long hex string, is my I forget the order, actually. It's either my public key. No, that's my signature that I just created. This one's my public key. And then an ACK channel, a return channel. So we're not currently using the return channel, so it just says bogus return. Okay, so that's good. So we did it. And now when I look back at my node output, let's see. There's a lot of debugging output here, but here's the deploy. It's the beginning of that code that I'm showing you in the browser interface. And then block 2 went around. So I'm officially a registered user of the status DApp now. I'm going to post a status presenting at RCON. I'll sign it. And then we have a nonce here, and this is also some under-the-hood cryptography. So if this were a real DApp that weren't for like teaching and learning purposes, this would be behind the scenes and the user wouldn't have to mess with remembering their nonce. But the basic idea is this. It's insufficient for me to cryptographically sign the string presenting at RCON. And the reason that that's insufficient is because if I use status DApp for a month and I've posted 100 statuses, then any attacker could look at any of my old statuses. I've sent my cryptographic signature out over the network already, And so they now have not only the status, but also a signature of that status with my private key. And so they could fraudulently change my status back to a previous status that I've posted. They can't change it to arbitrary statuses of their choosing, but anything that I've posted before, they can then repost on my behalf. So like, they could repost presenting at RCON, and then if people see that, they'll be like, what, there's another RCON going on? I didn't even know about it. Or any similar thing. Maybe I rage post when I'm fighting with my friend, and then they repost that a month later, and I get in a whole new fight. So it's an attack vector that you have to worry about. So instead of just signing presenting at RCON, I'm going to sign presenting at RCON and the number 1. And so every time I post a new status, that nonce increments. And so if they try to repost presenting at RCON, they'd have to sign a new nonce, and they can't because I have the private key. So here's what we're signing: presenting at RCON, comma 1, my password, sign. Up in the blockchain, we see that we got block number 3. That's the one where I posted a status. And finally, if I want to check my status, oh no. I hate when that happens. Oh, that's because I was supposed to start at 0. Okay, so let me try it again. Oh, by the way, I didn't mention that when you sign up for status DApp, you get a default status. I'm new here and haven't posted anything yet. I think I clicked sign there, so. Yeah, there's block 4. Okay, let's try again. Oh. Yeah, so I think, let's look at some of the debugging output here. You know how it goes when you code late at night and you don't remember where everything was. I thought the situation was that the nonce increments even when you get an invalid signature. So it was telling me correct nonce is 0. Oh yeah, so yeah, I guess you're right. Maybe it is still 0. We'll do a little team debugging here. Did it post? There's check. Oh, I'm not seeing deploys from my posts anymore. So, all right, I'm going to try this, I think, one more time, and then I'm not going to mess with it because it's not probably going to teach us anything, but let's just give it one more try. There's my public key, presenting at RCON 0. There's my password. Sign. Okay, we called up to the node. Okay, those aren't going through at the moment, so that's okay. You know, it happens sometimes. So, sorry about that. Okay, right. So, steps from here. I've given you a sort of a sense, an overview of what's possible and how this kind of development might be done. I've given you resources to some tools to help use RChain in a more user-friendly and developer-friendly way. Obviously, some of the tools still need a little bit of development, and so that's why they're not like on NPM, for example, or out in the public yet. But they will be soon, and feel free, to either report bugs or keep us honest about developing and pushing them on, or if you're an in-the-weeds developer like Dan is, to even submit pull requests or suggestions or anything like that. We'd love that, and it's one of the cool things about this community is that we all kind of work together to bootstrap the ecosystem. The nth caller DApp is actually an example DApp. I think I mentioned that you can clone and build yourself. And so we've got about 14 minutes left. I just want to continue to address any questions you might have about like developer process or how contracting works or anything else. Yeah, go ahead.
Could you please show like an example RPC call, like what is the request?
Oh, sure, yeah. I can definitely do that. You want to see the gRPC calls, the ones that go to the node, or like what I'm, yeah, sure. Yeah. So let me find the right spot here. Oh, actually, I don't even know if that's what you wanted to see. I think we want to look at RChain API. So this is the RCON API module. This is the one that runs on the, if you remember my figure, this one. This is what runs on the web server on the relay. So browser calls up via HTTP and the message gets relayed via gRPC. So the interesting stuff is in here. So there's all these helper functions like, buffer as hex. And so the basic idea is we have to serialize, anything we want to sign or deploy, we have to serialize the correct way to send over gRPC. And that's the part that it's not hard in a conceptual way in the sense that, like when you're learning advanced physics or something or a new programming language, it can be hard. It's just hard in the sense that like it's really bug prone and stuff like that. So let's see here. Buff to hex is written right here, but I mean, we didn't write it comes from JavaScript, it's a wrapper around this. So the part that you probably want to see is here. Oh, well, this is interesting too. So don't let me forget to get to what you actually asked me, but let me take a quick aside. This is the kind of stuff that's a pain in the butt to do and why we need a library for it. So what comes with the node is this Casper message.proto file, and it specifies the protocol for communicating with the node. So there's all these messages, or all these services, right? Like do deploy, and we give it the deploy data. And it's like, dude, that sounds awesome. That's what I want. I want to tell you when I want to deploy to our node, and I want you to do it for me, and then you can add a block, and it makes perfect sense. But then if you look like, okay, what do I have to deploy? It's deploy data. So let's see where we can find deploy data next. Well, here's what a deploy data message is. It's all this junk. And then some of them are not just primitives. Like we can see we've got a par in here. So let's see what par is. Oh, that's in a different file called row types. So here's what a par is. It also has a whole bunch of fields. And so you kind of like have to, Tomislav, you said this well the other day. It's like you're trying to parse an abstract syntax tree in your head when you're writing this kind of stuff. So that's basically what we're doing here. You see it's this like, and so what we're doing here is taking in JavaScript object. Because as a front-end programmer, I want to specify JavaScript objects. I like working with them. They serialize well to JSON, but we have to get them into this protobuf format. So we recursively go through the JavaScript object, testing what type it is, converting it to the proper like expert instance that appears in the proto file, and serializing from there. So I want to show you do deploy. I think that's what you were asking for. That's where I call to it. Here. Oh yeah, so so Dan's coding style is to abstract a lot of stuff away, so we also have to jump around a lot in here, but basically like what this function does, the one that we wrote here, it takes in a deploy data, which is, this thing, the Casper message.proto, and passes it onto the node. So let's see, am I actually familiar enough with this to show you what you want to see where we make a gRPC call? Oh, here's another, so here's something I haven't mentioned explicitly yet. Getting data back off of the blockchain, there's a really cool interface for that. You don't have to submit a transaction to the blockchain to read data out of it if you only want to know what's there without interacting with it. So for example, like when I'm checking my friend's status, I don't have to submit a transaction to the blockchain. I can call listen for data at name, and I can see if any data has been sent onto whatever name I specify. So the way we're doing it is with a public name by the method Jim described, where you kind of generate a random string and use that for your name. But this also works for unforgeable names once you figure out how to make unforgeable names off-chain.
Well, that's a name as like a deploy object, right? But
yeah. Oh yeah, no, what we specify, yeah, this represents a channel. This represents like a Rolang channel. Yeah, so let's see, it's, yeah, so we, again, to make it friendly for like JavaScript programmers, we take in JSON data basically, which is nice and easy to make in JavaScript, and then we turn it into, this is a protobuf item right here. So we wrote this helper method from JS data, which turns it into a protobuf serialization and makes an actual channel. And so this is the channel that we then send to this service listen for data at name. I don't know if that's interesting to you. I don't know that I'm going to be able to point you to exactly where we call the node. Okay. Yeah, cool. So I can tell based on that question, I think you should submit some pull requests to the the repository to help us get the rest of the API implemented. I'm recruiting you. Yeah. Okay, so what else can I talk about? Yeah, Jim.
Why don't you show us robot?
Oh, sure, yeah. So this is a project Jim and I and Dan and a guy named David, who's also not here, worked on this for, I think mostly you, and maybe you and David mostly worked on this.
We had it work with calling our node in REPL. Okay, you guys came in and helped call the gRPC.
Oh yeah, right. So you were you were using like the command line thin clients, like rnode deploy and rnode propose, and then like grepping or using a regex to find the right spot in the output, right? And so this is another mixed story because it worked before, and then we helped them convert it over to the RChain API, which is maybe a nicer solution, but it's not quite working yet. Jim, what channel is it? Should I try it on? Oh, and it's on all of them? All right, cool. So the way it works, this is what we're basically trying to do. Whenever you go into Discord on one of these channels that's installed it, you can start a message with rowlang : space, and then you can enter some rowlang code here. So this is like the dream in terms of, if you're debugging JavaScript, you might poke around and read stuff and evaluate stuff from like your console, or in Python they have like the PDB tool. So this is the way to poke into the tuple space when you're running on-chain or even a private chain like this with a Casper instance. So we'll start with one that's simple. We'll just evaluate like 1 + 1. On testnet, right?
Well, not the actual testnet, master or whatever that is.
Oh yeah. Okay, right. Because there's those 4 different bootstraps or whatever. So eventually, you can see this user over here, robot, is going to come back and going to tell us like the answer to that. So again, it's one of those things that has a little bit more debugging to be done. We'll see when it comes back. But it's cool because so perfect. There we got it. It sent us the success message that actually comes from the node, and then it also picked the answer value out of the correct spot in the tuple space. This is on, so the official RChain pub RChain is down here, but Jim actually, I'm glad this came up. Can I shill for you a little bit for a second? Yeah, so Jim runs the collab, collaborative laboratory, It used to be called like the Noob Work Study, and it's a bunch of projects where you come in and you learn by doing and you learn from your peers, and it's an awesome project. It's where I learned a bunch and where I've taught and shared knowledge a bunch, and so if you like to work with people and make new friends and do RChain stuff, Collab is an awesome place to spend some time and get some exposure. So it's actually where I met both Dan and David and Jim, I guess. So okay, yeah. What else can I talk about? Yeah. So you're saying like when I boot up a node, what was the question? Listen for data at name. Yeah. Oh, you mean can it like pull forward in the future? Like can I get updates? Yeah. So listen is an unfortunate name. What listen for data at name does is it checks whether there's any data at that name right now. It's not like a forward. See, yeah, what would really be awesome is if we could have like a JavaScript promise where you listen for data at name and the promise resolves when you get something. And we could maybe write that at the RChain API level, but it would have to be a solution where under the covers we're setting an interval and polling on a certain interval, and then we resolve the promise whenever we get it or reject the promise after a timeout or something. Yeah, I think even the thin client, you mean, where you can, I thought that only did it in real time, but my knowledge might be outdated on that. Yeah.
So you're saying for many apps, they will have to
Yeah, it's not a subscribe, right? Yeah, exactly. So yeah, like, I mean, one solution is that the Dap developer can do that. Now that we're talking about it, it seems like a nice thing that we might integrate into our chain API and put that messiness behind the scenes or under the hood. So, yeah, I think it's nice to not have to subscribe, because sometimes you just want to check and see if there's any data right now. But yeah, obviously it's also nice to subscribe, because, like, well, let's say we're going to try to decentralize Discord and put that on chain. Like, you know, I don't want to have to click refresh every time I'm looking for, like, you know, new messages on Discord. So, okay, well, I'll close it down there. Thank you guys so much for coming and listening to my talk. And, oh yeah, Vishwak, what's up? The nth caller game? Yeah, correct. Yep. Yeah, let me get some messages up here. So, like, one of these is what you're thinking of, right? Yeah. It's a block, and because I'm the only person on this network and I'm forcing a new block every single time I make a transaction, this block only contains my one transaction. But in general, like in you know, the test net or whatever, these nodes are aggregating deploys, such as post my new status or call and see if I won, or like make a new nth caller game. And then whenever they feel like they've had enough or enough time has elapsed or whatever the node's criteria is, they then aggregate these deploys and package them up into a block. So in this special case, it's blurred a little bit because I have one deploy per block. But in general, the blocks will have multiple deploys in them. Yeah. Hey, also I wanted to say Vishwak is the first person who's successfully completed my Write Your First Dap tutorial and built the nth caller game himself. So there's hope, and it's doable, and you all can do it too. So, okay, thanks a lot, guys. I really appreciate your attention and time today.